Hello everyone, welcome to my presentation for the Innovative AI Challenge 2024. The goal of this project is to increase agricultural productivity using an AI-powered crop yield predictor. This tool helps farmers by predicting crop yield in kg, total sack required, and also estimated revenue. Farmers can use this to make data-driven decisions, optimize their yield, and also boost profitable margins. Let's dive step by step in it. The first step is the data understanding. So our data include, as the dataset I have used had just 54 records with features like year, state, crop type, rainfall, soil type, irrigation area, and the crop yield, that is in the numerical form, which is the target variable. So the next step is EDA, Exploratory Data Analysis. The key EDA highlights are: I explore the numerical features, input-output relationship, and correlation. So let's dive into it. I have explored univariate analysis, bivariate, and multivariate. So explored rainfall, irrigation, and crop yield pattern. Also the bivariate analysis, which include irrigation area and crop yield. Also this, as you can see in the video, explore the relationship between categorical variable and the numerical variable such as soil type, crop type, state with the crop yield, which is in the numerical format. Also, I explored the relationship between year and average crop yield. Also this is the multivariate analysis, which include rainfall, irrigation area, and crop yield. Also, I identified the relationship for better feature selection by using the correlation, soil type, and crop type. So amongst all, wheat perform best in loamy soil, and while rice perform best in alluvial soil. After that, in the pie chart distribution, I visualize the proportion of crop types and soil types to understand the relative representation. After EDA, as the dataset is very small, so I have to do the feature engineering. So in data pre-processing part, I have to do feature encoding by label encoder, and also to apply the feature scaling with the standard scaler. I have applied the standard scaler for feature scaling part. Then the next step is the model training part. Given the limited dataset, I implemented k-fold cross-validation for model training part. So why I have used that? To get the reliable performance and to minimize the overfitting problem. I trained multiple models including linear regression, ridge regression, decision tree, random forest, and evaluate them using k-fold cross-validation. So amongst all, random forest perform best because it handles small data set well and it captures non-linear relationship effectively. So here is the score of random forest by using MSE metric and also R2 square. The model achieves high accuracy, making it reliable for predicting crop yield. So after this step, I use hyperparameter tuning. I use this technique so by optimize this hyperparameter using this technique like random search CV to identify the best configuration, where we have using the random forest regressor. So by hyperparameter tuning, we can enhance our performance and get the best parameter. So after getting the best parameter, I have fit that model in the final model and train the model, that is the random forest regressor. And the final step is model evaluation. I have used the MAC and R2 score. So this model demonstrates excellent performance on crop yield with a low test MAC around 40,000, 43,000 and high R2 score around 98.60, which indicating accurate and reliable forecast for agriculture decision making. Now I have also predict the feature importance by random forest. So by explore the feature importance, which feature is more important in the dataset. The one is the irrigation area and crop type. Now the final step I have submitted. I have submitted the model and got this crop yield in that format. Then the next step is the UI implementation part. As you are seeing, it is a GitHub link and crop yield predictor UI. Let's dive into it. Let me show you the farmer-friendly interface I created using Streamlit. This one. So the farmers can input soil type, crop type, year, irrigated area, MSP, which will be given by the government, and sack size. Then it will predict predicted yield, equivalent sacks, and estimated revenue. So I can show you the example. For example, loamy, the crop for loamy, the recommended crop types will be wheat, rice, bajra. So I can go with the wheat. 2019, enter. 3515.20. We can enter the irrigation area, which is in hectare, and convert it into acres. The minimum price for the 50 kg sack is 20. Now we can predict. The predicted yield, total predicted yield is around 16,88,000 something. An equivalent sack is this, an estimated revenue in crores. Now, the behind the scenes, here is a quick overview of the code, GitHub, where it contains app.py, requirement.txt, and the pickle file. Here is the app.py. Now, the main challenge I have faced in this project is that There is a lack of features. There is a the first challenge I have faced is the irrigated area conversion. Farmers typically use acres, so I added this conversion. You can see hectares, which multiply by 2.47, then it will be converted into acres. And also sack size, I have to create the sack size, total sack size. Now the converger part is this. So the first is the model prediction. Inputs are proceed and yield is predicted in kg. Then the conversion part, as you can see, total yield and total revenue I have calculated. And the last one is the UI output. Results are displayed in a clean, easy to read format. And then now last is the deployment and closing part. So I deployed this app on Streamlit, and you can access it here by clicking on the crop yield predictor. And also I have attached the GitHub link in my Kaggle notebook, so I will provide it that also. So the conclusion is the farmer-friendly crop yield predictor empowers farmers by providing actionable insight to improve productivity and profitable margin. Despite challenges like limited data, missing features, and converting metrics into user-friendly output, this project demonstrates how AI can transform agriculture. I invite you to explore the app. So yeah, this is my farmer-friendly crop yield predictor. So final call, I have to say that if you find this project interesting, or if you find this project is very interesting, to please subscribe for more AI project. Comment your questions or feedback. Share this video with others. Thank you so much.